Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithms series. In this series, we are going to learn and solve problems related to data structures and algorithms using Scala functional programming approach. In this video, we are going to discuss about Sudoku puzzle. So what is a Sudoku puzzle? Sudoku is a 9 into 9 grid divided into 3 into 3 blocks. What are the rules to play Sudoku? So each row must contain unique value between 1 to 9. Each column must contain unique value between 1 to 9, and each 3 into 3 block within the grid must contain all unique values between 1 to 9. One possible solution to Sudoku is via backtracking. Backtracking is a recursive algorithm. So we start with the first index, that is 0, 0, 0, and we check for the constant. If that constant is satisfied, we add the number. If not, we backtrack to the previous. So if it is starting with the first value, obviously there is nothing that we have to backtrack. We can put random value there, then we move to the next cell. And similarly, if that constant is satisfied, we move to the further next, and if there is any constant violation, we backtrack and find the possible solution. Backtracking can be optimized using constant propagation and minimum remaining values that we are going to see in action when we are going to implement this solution. Coming to time complexity. Time complexity of backtracking algorithm in this case takes O(n)m in the worst case scenario and also in the average case. So what happens is, for every unified cell there are n possibilities to explore and there are m unified cell in the Sudoku. But in case of best case, time complexity reduces to OM square. This takes place when the number of backtracking steps are minimized. So given that, we reduce our options, and we will see that in action when we are going to implement this. Coming down to space complexity, at most there can be m function calls in the recursion stack, hence the space complexity would be OM. Alright. So let's directly go to the code and see how it looks like. I have created an app here which will be using randomizer to import or randomize the values, and this is the Sudoku grid. This is how it is going to look like, where all the rows are unique and all the columns are unique. Take any cell in this block and you will find all the rows are unique and columns are unique. Similarly, if you go to the 3 by 3 matrix, you will see all unique values. Alright, so let's start the implementation. Alright, before we start, so I have divided the Sudoku puzzle solution in two parts. In part 1 we will be implementing the constants, and in part 2 we will be implementing the Sudoku board itself. Alright, so let's start implementing the constraint. Let's create the Sudoku grid. So Sudoku grid will have a value of 9 because it's going to be 9 into 9 matrix. Now let's create a default sequence. So it is going to be 1, 2, 3, 4, 5, 6, 7, 8 and 9. You can use range to do this. I have done it explicitly to make it more verbose. Alright, now we can see how it works. We will randomize it. So we are using random from Scala util dot shuffle, and we are going to give default. So what it will do is it will randomize it. Let's print it and see. Print ln b. Expectation is the value will be randomized. Every time we run it, the value will be randomized and we will get a different sequence in total. So randomizer we are going to use to pick the values whenever we are going to run the Sudoku. Alright, so it is 7 now. If we run it again, so the head is going to change. Alright, it is 6 now. So we are sure that every time we randomize, we get a different value. Now, let's comment this out. Let's implement the Sudoku itself. First, let's have the empty Sudoku or the default Sudoku. It will have all the values array.fill. It will have dimensions of Sudoku grid, comma Sudoku grid, and it will have default value as -1. All right. So we are going to use sequence of int as our Sudoku board. In process, we will transform it to sequence of int whenever we need, and we will fetch the values for our constraint. So let's implement the constraint. Let's create an implicit class and let's name it as Sudoku constraint, which will be on top of, say, sequence of int. All right. First, inside this, let's break this into sequence of int. So let's create it as new sequence, which will be sequence dot grouped by Sudoku grid. Alright, so this will return an iterator. We have to now convert it to sequence of int. How we are going to do it? So fold left, sequence of int, default value as nil. Now let's create an accumulator, a higher order function we are going to pass here, and it is going to just append the value. Alright, this will give me sequence of int. Now it will somewhat look like our Sudoku. Let's implement the constraint. First is get the box. So we will say get box. Alright, so we can say get box. Yeah, it might be. So we give a value as index, for which we want to pull the uh, entire, because what we need is whenever we have an index, for this index we will need all the column and all the row to get the to reduce on the number of selections. All right, this is one method. Second method would be that we need basically to get the matrix data itself for the row and column. So we can say get get matrix data, which will also take an index and which will return a sequence of int. All right. So these two methods are our constraints. So this first one, it is will return the value for the given value for the box for given index, and this is going to return the row and column for the given index. Return the values. It will also be our values. All right, let's implement this. Okay, now watch closely. This is going to be a little tricky. So it's going to be val m comma d. You can name it whatever variable you like. Now we are using index to get the row and column value. idx percentage Sudoku grid, comma idx mod, divided by Sudoku grid. Alright, this is going to give me the row and this is going to give me the index of this. Now I have the value as row and column. Now let's implement a pattern match. What all possibilities we can have? Now because we are going to get the block size of 3 into 3, so we have 9 blocks. So in first row we will be having 3 into 3 blocks, or 1 into 3 blocks, first, second, third. Now for any index, like I have a value 9, I need to get all the values associated from 614, 798, 235, everything. It cannot go to this level. So I need to create similarly. So for this three records, there will be three cases. Again for next three, there will be three cases. Again for next three, there will be three cases. So in total, we are going to implement 9 pattern matches. Now you can have a mathematical method, a function around this to do this. Pattern match will make it more verbose to understand what is going on in each case. Alright, so first case is case M1 if M1 is less than equal to 2. So this is the first block itself. Alright, so what we are going to do? We are going to do a pattern match on D. Now let's say D1 if D1 is less than equal to 2. So now what will happen if D1 is less than equal to 2? So we are going to do 0 to 2 dot flat map. Alright, you can replicate this with for loop as well, which will be your row, and again 0 to 2 and then dot map, and this will be C. Now it is going to be new sequence and we are going to enter R and then C. Alright, this is the first pattern match. Okay, here I have to implement this flat arrow. Alright, now this is the first case. Similarly, let's copy this entirely and paste it here. Next case would be if my D is less than 2. So I can say my D is greater than 2. So first is less than is done, greater than 2 and less than 6. So it will be between 3 to 5. So 3 to 5 is this one, 3 to 5. So this will be the case, the second block that we are going to address. Okay, so again if it is alright, so we have to add and D1. Okay, yeah, now it is fixed. So what we are going to change? We are going to change this one 3 to 5. Alright, and this will remain same because we are targeting the first row itself, the first column, basically first three columns. Alright, now the third case. Now we are shifting our window, so now the third case will be 6 to 8. Alright, so similarly here it will be value 5 and it is going to be less than, or it will be greater than 5 will be enough because it cannot go beyond 9. So here we are going to add 6 to 8 and rest of them will remain as is. Alright, so we have implemented the first pattern match successfully. Now let's go to implement the second pattern match. So second will be case when your M1, similarly like we did the comparison for this one, we will be doing it if your M1 is greater than 2 and M1 is less than 2. So let's make it 2 here and let's make it M1 and M1 is less than 6. So M1 is from 3 to 5. Alright, so what we are going to do? We are going to do a pattern match on D again. Alright, here again same thing. We are going to copy this. Let's do D. So let's copy entire thing. Alright, and watch closely. So here we were going from 0 to 2. So it will be 0 to 2. But here this is going to change from 3 to 5. Alright, now let's move on to the next case. Let's copy this. Okay, let's copy this one. Alright, so in the second case it is going to be 2 d1 and d1 is less than 6. Perfect. So it is going to be 3 to 5, but here it is going to be 3 to 5 again because we have shifted our grid. Now, not the grid but the box. Alright, so let's copy the third case. Here again d1 is less than 5, so it is going to be 6 to 8, correct? But here it is going to be 3 to 5. I hope you guys are following. Alright, so now our next case. Next case again, as we know that the next case would be case where our m1, and if m1 is greater than 5. So it means that it is from 6 to 8. Alright, same thing, D match. Alright, so here we are going to again do the same pattern match what we see here, but with a slight difference. Alright, so here it is going to be 0 to 2, but here we are going to change it to 6 to 8. Again, we will copy the second method or the second pattern match here. Here again it is 2, d1 is less than 2 and d1 is greater than 6. It is going to be 3 to 5, but here it is going to be 6 to 8. Alright, now the third pattern match. Alright, so here it is going to be 6 to 8 again. As before, it is going to be 6 to 8 here as well. So now we have captured almost everything, but to be on safer side, let's have a default case. Always have a default case. This will prevent you from any error that you are going to see or have, which is going to return a nil. In case if we run out of numbers, then we will go to nil. Alright, now this implements the get box. Let's go for the second method, that is return the value for row and column for the given index. This is going to be pretty small because as you have seen it, the complicated part is done. So let's implement this method. Okay, we are going to do same thing, so let's do it. Val c comma r equals to, so we will be doing same thing, idx percentage Sudoku grid comma idx divided by Sudoku grid. This is going to be column and row that we are going to see. Alright, so let's do to 0 to Sudoku grid dot map. So it is going to be CL, and this is going to be new sequence, and this is going to be CL comma C, and we are going to add. So this is, we are collecting all the column level records or the row level records, and we are going to do same thing again, 0 to Sudoku grid dot map, and we are going to collect the row level information. So it is okay, here it will be like this, that is why it is throwing an error. Alright, so it is going to be r comma rw, so this is going to give us the row level information. Alright, so this two methods complete the part 1 where we have implemented the constant. In the next video we are going to see the final implementation of the Sudoku grid. Alright, so if you enjoyed this video, please like and subscribe, and see you around in the next video. Thank you.